Hey there, Seahawks, it's Miss Adams, and in this video, we're going to learn about sampling distributions of a sample proportion. The sampling distribution of the sample proportion p hat describes the distribution of values taken by the sample proportion and all possible samples of the same size of the same population. So, how to calculate the mean and the standard deviation of our sampling distribution for sample proportions. The mean of the sampling distribution is equal to P, which is your population proportion. If you don't know that, then you would use P hat. The standard deviation of the sampling distribution of P hat is equal to the square root of P times 1 minus P over N. That should be a 1 minus P, not P minus 1. Note these formulas are true for the sampling distribution of P hat, no matter what the shape is. Important facts about the mean and the standard deviation. The sample proportion P hat has an unbiased estimator of the population proportion P. The standard deviation of the sampling distribution of P hat describes the typical distance between P hat and the population proportion P. The sampling distribution of P hat is less variable for large samples. And the formulas for the standard deviation of the distribution of P hat requires that the observations are independent. All right, an example finding the mean and the standard deviation. Suppose that 26% of all high school students at a large school spend half or more of their earnings on a car. A random sample of 150 students from this school is surveyed. Let P hat equal the proportion of students in the sample who spend half or more of their earnings on a car. Calculate the mean and standard deviation of the sampling distribution of P hat. So the mean of the sampling distribution is going to be equal to P, which is 26% or 0.26. And the standard deviation is the square root of 0.26 times 1 minus 0.26 over my sample size of 150, which gives us 0.036. Interpret the standard deviation from part A. So in a simple random sample of size n equals 150, the sample proportion of students who spend half or more of their earnings on a car typically varies from the true proportion of 0.26 by about 0.036. All right, the large counts condition. Let P hat be the proportion of successes in a random sample of size n from a population with proportion of success P. The large counts condition says that the sampling distribution will be approximately normal if n times P is greater than or equal to 10 and n times 1 minus P is greater than or equal to 10. So the shape of the sampling distribution of P hat. To audit one department of a large corporation, an accountant selects a random sample of 80 transactions. Historically, the true proportion of transactions are more than $1,000 is P equals 0.42. Would it be appropriate to use a normal distribution to model the sampling distribution of the sample size n equals 80? Justify your answer. So we're going to say yes because n times P, n is 80, P is 0.42. Gives us 33.6, which is greater than or equal to 10. And n times 1 minus P, which would be 80 times 1 minus 0.42, gives us 46.4, which is also greater than or equal to 10. So the sampling distribution of P hat is approximately normal. All right, in a recent year, a fact sheet for the state of Pennsylvania stated that 72.6% of all public high school seniors were planning to attend college the following year. Suppose you survey a simple random sample of 400 public high school seniors in Pennsylvania and ask them if they are going to college next year. Let P hat be the sample proportion who are going to college next year. Describe the shape, center, and variability of the sampling distribution of P hat. So the shape would be approximately normal. Again, we would want to check n times P. 400 times 0.726 is 290.4, which is greater than or equal to 10. And n times 1 minus P, which gives us 109.6, which is also greater than or equal to 10. So the shape would be approximately normal. The center is going to be our mean, which is going to be 72.6% or 0.726. And our variability is going to be the standard deviation, which is the square root of p times 1 minus p over n. So when we calculate that, we get 0.022. Find the probability that a simple random sample of 400 students will give a result within 3 percentage points of the true value. So I have a normal distribution with a mean of 0.726 and a standard deviation of 0.022. I'm going to put 0.726 in the center, and then within 3 percentage points, so I'm going to go 3 percentage points below and 3 percentage points above, which would be 69.6% and 75.6% if I add and subtract 3 from both sides. I want to find this area in between, so I'm going to use a normal CDF. My lower bound would be 0.696, which is 3% below 0.726. My upper bound would be 0.756, which is 3 percentage points above 0.726. My mean is 0.726, and my standard deviation is 0.022. When I throw this into my calculator, I get 0.8273. So there's a 82.73% chance that the student will get between 3 percentage points of the true value. All right, go Seahawks.